Okay, good morning. Happy Monday, Transitional Algebra 2 students. Mr. Pashar here once again. Hope everybody had a great weekend. Very sunny. For once we had the sun out. Feels like we haven't seen it in years. Nice and warm. Taste of summer, I think, looking out the window today, doesn't look too bad. Looks kind of sunny. Not as warm today, but around 60 degrees. Should be your high temperature, and no chance of precipitation, I believe, as well. So today we embark on a new topic. It corresponds to lesson 6-8 in your textbooks, which is the imaginary numbers. This is a topic I always liked even when I was in high school. I remember when I first learned about imaginary algebras in a course called College Algebra. I thought it was a kind of a fascinating topic at that point, and I still think it's a fascinating topic. And believe me, we're only going to look at the tip of the iceberg here, but there's a course in college you could take. It's called Complex Analysis, which is all about the mathematics of the complex numbers in algebra, trig, and in calculus. So it's a kind of a nice course to take. You take it if you're a math major. Even if you're going to minor in math, you can still take the course. So for anybody who wants to be a mathematician someday, it's an interesting course. It opens up your mind to a lot of things. Today I'm going to talk about the basics of the imaginary numbers, and then next week we're going to talk about the complex numbers. But let's talk about how we may see these things. For example, we have an equation that we might want to solve, like x squared equals 4. So this is a CCTI equation, but it's a nice quadratic. The way that you solve something like this, as you're going to see in your notes and in your textbook, is if you have x squared on one side and then a number on the other, what we do is we take the square root of both sides. So the square root of x squared is x, and the square root of 4, as you know, is 2. But we have to call this plus or minus 2. And the reason why we call it plus or minus 2 is because if we have x squared, x is your unknown, that could stand for 2 being squared, which gives you 4, but it could also stand for negative 2 squared, because doesn't that also give you 4? So whenever you solve an equation like this, it's going to be plus or minus that number. Now sometimes we don't get lucky like that. Say we have x squared equals 8. Well, we do the same thing. We take the square root of both sides, and we get x equals plus or minus the square root of 8. 8 is not a perfect square, therefore we're not going to have a nice concrete number. But we can reduce something like the square root of 8. And the way that we do that is we break that down to 4 times 2. And then we can break 4 down to 2 times 2. And then whenever you have a square root, you always take things that are alike out in pairs of 2. So you see how you have 2 2's here? One of those 2's will come out in front, and this guy's trapped underneath. So the answer here is going to be x equals plus or minus 2 root 2. That would be your final answer in that case, okay? And I gave you a bunch of examples in your notes that I emailed you this morning, so make sure you look over this. But here's where the imaginary numbers come into play. And this goes back a long, long, long time. Before our grandparents and their grandparents were born and their grandparents were born. We want to solve an equation like this. X squared equals negative 1. So we go ahead and we take the square root of both sides. But what in the heck is this thing? The square root of negative 1. What exactly is that? If we had the square root of 4, that would be 2. Because what number multiplied by itself gives you that number? So it's 2. So what number multiplied by itself gives you negative 1? Well, you're never going to find such a number, are you? It's impossible. Because if you take negative 1 times negative 1, that gives you a positive 1. If you take positive 1 times positive 1, that gives you positive 1. It doesn't give us this negative. So this phenomenon kept occurring in mathematics. So mathematicians had to devise essentially a new set of numbers that would combat this, and we call them the imaginary numbers. So by definition, whenever you have the square root of negative 1, that is equal to something called I. I is what we call the imaginary unit, and that's how we handle something like this. So I is the imaginary unit that stands for the square root of -1. So for example, if I have the square root of -4, this is going to be 2i, because the square root of 4 is 2, but because it's negative, we have to put the I with it. So the answer would be 2i. So there's a theorem that we have. The theorem says the following. It says if you have the square root of -k, what that means is you got I times root k. So if you have the square root of -k, we write that immediately as I root k. So going back to this example of the square root of -4, we can immediately write this as I root 4, but we know better that we can simplify that, so this is going to be 2i. Okay? And I always write a cursive I myself so it doesn't look like number 1. What if we had the square root of -8? We saw root 8 before. Well, by using the theorem, again, if you have a negative number under a square root, the I immediately comes out in front. So we have I root 8. And then we saw before that we could simplify the square root. We saw before that we could simplify the square root of 8 as 2 root 2. So this is going to become 2i root 2. Okay? So that's how we handle these negative square roots. We call these imaginary numbers. And I gave you plenty of examples to follow in your notes. Now sometimes these are a little bit harder to break down, so we'll look at a couple other examples. I think it's kind of neat that we have this set of numbers, and an interesting fact is, in history, for many years, actually you could say many decades, mathematicians refused to believe in these square root of negative numbers as I. They rejected it. So work in some areas kind of slowed down, guys, because mathematicians refused to work with these things. So they kind of just put those problems off to the side and said, screw it, I'm not going to deal with this now because I don't believe in this garbage. Let's say we want to simplify something like the square root of -54. So what this is, the theorem says that if it's a negative number underneath, we pull the I out immediately. So we got I root 54. And by the way, this is multiplication, right? You could think of I as a variable, like an X if you want to, but it's an imaginary unit. Now, how do we break down 54? Well, if you know your times tables, 9 times 6 is a great start. So 9 is 3 times 3, and 6 is 3 times 2. We pull things out in groups of 2. So we have 2 3s, so that comes out as a 3. So we got a 3i times, now 3 times 2 you can't do nothing with, so we'll just put it back as 6. So the square root of -54 is equivalent to 3i times root 6. Okay? So that's how you simplify such a thing like that. So again, we use this because now we can solve equations with it. For example, you've got x squared equals -4, right? We take the square root of both sides. Now when we do this, remember, this is always going to be a plus or minus. So in an equation, when you solve it, and you take a square root, always a plus or minus. If it's no equation, and you're just simplifying a square root, you don't need the plus minus. See up here, we didn't need plus minus, but because this is an equation, we have to have the plus minus. So x squared equals -4, this is going to be x equals plus or minus 2i. And that would be your solution set, plus or minus 2i. Okay? That's how you would do that. So just make sure you read the examples. Now there's another thing that we could talk about, is that the imaginary numbers, for the most part, with the exception of division, for the most part, they behave just like all our things in real numbers. So that means we could add them, we could subtract them, we can multiply them like normal. However, there is one thing that we do have to be cautious of, and it goes by definition. So again, if you remember a couple things here, we have I equals the square root of -1. If we ever have an I squared, so that means if we take I times I, that gives you I squared. Whenever you see I squared, you have to immediately write that as -1. And that is a very important idea. I squared is -1. And in fact, in the upper classes, you'll learn that there's actually a pattern. If you go I squared, I to the third, I to the fourth, I to the fifth, I to the sixth, and so on, the powers of I are cyclical, right? And they form what we call cyclic group in abstract algebra, but that's a little bit beyond what we need here. But this is important. Whenever you see I squared, you're going to go ahead and rewrite that as a -1, okay? So we could do all kinds of things. We could add, subtract, and multiply like normal. For example, now let's take something like this. Say we have 4i times 5i. 4i times 5i. Well, do the numbers like usual. What's 4 times 5? That's 20. Now we have I times I, that's I squared. So technically we're not done. We have to finish this off. So 20i squared is 20 times -1. Because remember, I squared stands for -1. So this is going to be -20. Okay? How about something like this? -7i times 8i. Well, -7 times 8 is -56. And then I times I is I squared. So this is going to be -56 times -1, which turns out to be +56. So something interesting takes place here that you should be aware of. Whenever you multiply two imaginary numbers, okay, these are imaginary, these are imaginary, what you get back is a real number, and that always happens. If you remember from class, I always would say there's 3 words that we hear in math. Always, sometimes, and never. This is an always thing, people. When you multiply two imaginary numbers, you're always going to get back another real. Always happens. Let's see, how about we do something like this? How about, let's do the square root of -9 plus the square root of -49. So the rule says that if you're adding radicals, you can only add them together if they're the same. So for example, both of those things are not the same numbers underneath, so we can't add them together. But they're negative numbers, so that means we could go ahead and convert them to imaginary numbers. So the square root of -9 would be 3i, plus the square root of -49 is 7i. So what's 3 plus, you can think of this as like 3x plus 7x, right? So 3i plus 7i would be 10i. So the i goes along with this. You can think of it as like 3x plus 7x, or 3w plus 7w, whatever variable you choose, okay? Now I will show you division. We just have to be a little bit careful. We're just going to look at some basic things. Say we have something like -64 over square root -4. So suppose we have that situation, right? What we got to do is simplify. So square root of -64, that remember is going to be I root 64. And the square root of -4, that's I root 4. And then square root of 64 is 8. So this is going to be 8i. Square root of 4 is 2, so this is 2i. And you can legally chop here. It is possible. 8 divided by 2 is 4, and I divided by I, they're gone. So look what happens here. When you divide two imaginary numbers, you get back a real number. Interesting, kind of like with the multiplication, right? So that's a thing that can happen. Now sometimes you may see problems where we can't simplify square root. In this example, let's say we have the square root of negative 100 over the square root of negative 2. So the square root of negative 100, right, that's going to be I root 100. And on the bottom, this is going to be I root 2. Square root of 100 is 10. So we have a 10I over I root 2. Because the square root of 2 is one of those enigmas, right, if you think about it. It is an irrational number. We can never simplify that. Its decimal representation flip-flops all over the place. It's just an approximation, 1.42, I believe. So what can we do here in this case? Well, you can't cancel the 10 with this 2 under the root, but they both have an I. And since we're multiplying here, 10I and I root 2, we could get rid of the i's and call this 10 over root 2. So 10 over root 2 is an acceptable answer. Okay? Now, let me show you something though. And you're not going to have to do this, but this is noteworthy for those people that's going to be going on the geometry or in the pre-calc, is that if you have something like 10 over root 2, usually we have to do something called rationalization. We don't like having a radical in the bottom. So what we do is we multiply the top and bottom by that radical, and what that does is it springs that number out. So root 2 times root 2 is just 2. You see that? Any number under a radical times the same radical is just that number underneath. And 10 over 2 is 5, so this would be 5 root 2 if you do something called rationalizing or rationalization. The slick trick that we use in all branches of math, because mathematicians are funny like that and they don't like having radicals sometimes in the bottom. Okay? And that is pretty much covers everything for the basics. Probably want to pause the video, go back and redo the problems. But what we learned here again is how to solve a basic quadratic equation by taking a square root. And how do we do that when we have a negative square root? We introduce the imaginary numbers. The imaginary numbers are the answers to those square roots that have a negative inside. And then we learn how to add, subtract, multiply, and special cases of division for this in terms of imaginary numbers. So I hope this video will help you. As always, if you have any questions, please feel free to call or email me. Your assignment is emailed to you. If you didn't get the email, let me know. Well, I guess if you didn't get the email, you're probably not watching me unless your friends told you on Snapface or something like that, or Facebook. But again, I hope everybody's doing well. Please, if you have questions, feel free to ask. Until next time, this is Mr. Pashar, hoping that you're doing well and enjoying your day, and I'll see you next time.